All right, question number 2. I like this question. I really do. I also think that this is the sort of question that the curriculum is really interested in students being able to answer here. Explain an algebraic strategy you could use to show that a particular linear quadratic system of equations has no solution. How could you then tell if it had a single solution? Basically, how can you tell in this given scenario here whether or not this thing has a solution or not? So now I'm just going to kind of zoom in here. Well, this is what we might do here. Let's just say that we've got a quadratic. So y equals ax squared plus bx plus c. Okay, and I've got now a linear equation here. Now, normally I would say that my linear would be like ax plus b, but I'm using the letters a and b up here. So I'm just going to create a different equation here. Let's make this dx plus e. Okay. It just has to be a linear here, which means the degree on the x has to be 1, and so d and e are just my leading coefficient and my constant. Now, what would I do to solve this system if I actually had numbers here? Well, I would set the quadratic equal to the linear because they're both equal to y here. So what I would get is ax, whoops, sorry, that's not what you'd get. You'd get ax squared plus bx plus c equals dx plus e. Okay, this is a quadratic, so to solve it, I would bring those terms over, so I would get ax squared plus bx, now minus dx, I'm going to deal with that in a second, plus c, oops, sorry, minus e is equal to 0. Now, I'm gonna put brackets around these two terms and brackets around these two terms because they are going to be like terms here. So this is going to end up being ax squared plus, okay, b minus dx plus at the back end here, c minus e equals 0. Now, how could I tell that this has no solution or it has one solution? Well, you go back to a tool that we've been using basically throughout this course here. We're going to check the discriminant. Now in this case, the discriminant is going to have the value b minus d squared minus 4 times a times c minus e. Okay? Now, if this is equal to, if this is negative, okay, no solution. And just like it was back when we were studying quadratics, if this is equal to 0, it's going to have one solution, okay? It's going to have, now remember, equal to 0 typically meant 2 equal real roots, but really what that amounted to was one x-intercept, so one solution. So that's how you're going to know. If the discriminant is less than 0, no solution. If it's equal to 0, one solution.